The main type of upgrade used in MCUboot is called a swap. We will go into some detail about this here, as it constitutes a majority of the complexity of the code in the bootloader. We will cover some alternatives later. At this point, the flash is in this state shown, with the previous image living in the primary slot, and the desired new image in the secondary slot. I will not include the upgrade marker in this animation to keep things a little bit simpler. Before it begins doing the upgrade, it verifies the signatures on the image in the secondary file. If these are not valid, or this image is somehow inappropriate for this device, it will just proceed and try booting the primary image. The trailer. At the end of each slot, there is an area known as the trailer. This contains a magic value, a few flags, and a series of progress indicators. I will show the progress indicators with these little squares. What is important to understand is that this trailer is designed so that the progress can be indicated without having to erase the sector. At the beginning of this process, we store this state at the end of the scratch area. Unlike the rest of the image, this area is not copied from the other image, but written freshly in order to indicate state. The state that indicates the start and finish of the operation is not shown here to keep the illustration from getting too complicated. Moving the segments through swap. The swap itself happens when chunks of the image the size of the scratch area, which must be a multiple of the sector size. The first few copies are handled a bit specially because of the trailer at the end. Each time one of these swaps completes, the appropriate marker is written in the trailer area, with the first two being written in the scratch area. Once we've completed this second copy, we can then write the trailer in its final location at the end of the primary slot. The remainder of the status will be written here. MCUboot continues this swap operation on each chunk, updating the markers at each stop. This is all done carefully and specifically this way so that it can resume where it left off in the case that there is an untimely power down. The done indicator. Once all of the chunks are completed, we have completely exchanged the contents of the two images. The old image is in the secondary slot, and the new image in the primary. At this point, the code sets a copy done flag in the primary slot, and can then begin executing that code. If a later execution determines that this image does not work, the swap operation can be repeated, which will place the old image back into the primary slot, effectively reverting the upgrade.